Hello, good morning students. Today we are going to discuss about the Aldol reaction. The most important condition that we require for Aldol reaction is that the reactant must be any carbonyl, that is aldehyde or ketone, and that must contain alpha hydrogen at the sp3 hybridized carbon. That alpha carbon with respect to the carbonyl group must be sp3 hybridized. That should be present at the sp3 hybridized carbon, and the reactant here is any carbonyl, that is any ketone or aldehyde that must contain hydrogen at the alpha sp3 hybridized carbon. The reagent here can be base like NaOH, and the product here first we will form aldol addition product, then after that we will form aldol condensation product. So our reactant is any aldehyde or ketone that must be having alpha hydrogen. Let's see. This is having hydrogen present at this alpha carbon, which also we can see is sp3 hybridized, so we can take this as a reactant. Also this can also be taken acetone, this can also be taken, but we cannot take any compound, any aldehyde or ketone that is not having alpha hydrogen. Suppose these are 3 carbon atoms attached to this alpha carbon. This is not having alpha hydrogen, so we cannot use this. We cannot use this, but we can use this and this. This can be taken. And the reagent is the base, and the product is aldol. This aldol is also known as beta hydroxycarbonate. If we are using ketone, then then we'll get beta hydroxyketone. If we are using aldehyde, then we will get beta hydroxyaldehyde. Here we have taken this. This is aldehyde. This is our alpha carbon, and this is containing hydrogen. Hydrogen is present at this alpha carbon. So the first product that we will get here is beta hydroxyaldehyde. This is aldol addition product. We have taken two equivalent of this aldehyde, and they have combined to give this aldol addition product. And when elimination reaction takes place, condensation product is formed. This condensation product is known as alpha beta unsaturated carbonyl. Here we have aldehyde, so we can say that this is alpha beta unsaturated aldehyde. So here we have our main carbonyl group. This is alpha carbon and this is beta carbon. So alpha beta unsaturated carbonyl. Here this is alpha carbon and this is beta carbon. That's why this is beta hydroxycarbonate. This is aldol addition product and this is aldol condensation product. One more interesting thing, why we have given name aldol to this compound is because we have aldehyde, we have alcohol. So let's see here, aldehyde and we have alcohol. This contains aldehyde and alcohol. So take ALD from here and OL from here. What you will get? You will get aldol. So this is how its name has been kept. Aldehyde plus alcohol. This is present in the same compound, aldol addition product, and we say it as aldol. Now move towards the mechanism of this reaction. Come to mechanism. We may divide it into two steps. First step, deprotonation of alpha carbon, that is enolate formation. So how enolate is formed? The base from our reagent, this will go and attack here on the alpha carbon and will fetch hydrogen. Then we will get CH2 minus CHO. This may also show resonance and may get stabilized by this effect. Step 2 is the aldol addition and protonation. The enolate that we have formed, that will go and attack on the carbonyl. This will be nucleophilic attack by enolate on the carbonyl, which is electrophile here. So nucleophile plus electrophile. Then what will happen here? This will go and will attack here and this. So what will get? We will get a new CC bond will form here. A new CC bond has formed here. This is the new bond. This one is the new bond. And further, what will happen when we will have this reaction? Then this water molecule will protonate this, and we will get the final product, aldol addition product. This is our product. This is our product. This is hydroxy. This is aldehyde. And this is our aldol addition product. This one. This is alpha carbon. This is beta carbon. Beta hydroxy because of presence of OH group. Aldehyde. Beta hydroxy aldehyde. Aldehyde. We have taken initially, that's why this is aldehyde. So beta hydroxy aldehyde is the aldol addition product here. Heating the aldol addition product in presence of base leads to the removal of water molecule. This gives us another condensation product. Removal of water molecule gives a new CC bond. From that we get the final product as alpha beta unsaturated carbonyl. So this aldol condensation product mechanism for this can be divided into two steps. The first step is deprotonation, that is enolate formation. This OH will go and extract this hydrogen, then this will move here. We will have this. Then in step 2, this may be considered as step 2. This is our step 2. Step 2 in which elimination of OH group will take place. This will go here and this will be new. So this bond comes here. This is the new CC pi bond. This OH gets removed, and this is the final alpha beta unsaturated carbonyl or alpha beta unsaturated aldehyde. This is alpha carbon and this is beta carbon. This is the aldol condensation product. This is the aldol condensation product. We use base and heat here. Heat tends to favor the elimination product. This is example of even CB elimination, not E2 elimination, which takes in one step. Here you can see this is in two steps. This is even CB. Now look at some examples. Here, this is alpha carbon, this is alpha carbon. Alpha hydrogen is present here, alpha hydrogen is also present here. So this can attack on any of the alpha hydrogen. So this may attack here and extract this hydrogen, we will get this. And when this product will attack on this carbonyl, this will be the nucleophilic attack, then this will move here, we will have OH and there will be a new CC bond between these two carbons, and hitting the product in presence of base, will get aldol condensation product. First we will get here aldol addition product, then after we will get aldol condensation product here. Second example, acetone is there. This is a ketone. This was also a ketone. First we had used aldehyde. This is ketone. This has two alpha carbon. This is alpha carbon. This is alpha carbon, and hydrogen is also present at alpha carbon. So what will be the product? First, this OH minus will go and can extract any of the alpha hydrogen from these two carbons. Will have CH2 minus enolate. Then that CH2 minus will go and attack on another molecule of acetone, and aldol addition product will be there. Take this as the aldol addition product, and when this aldol addition product, then this will be treated with OH in presence of heat, then we'll have this one as the product. This is alpha beta unsaturated carbonyl, particularly ketone, alpha beta unsaturated ketone. This is the aldol condensation product finally that we have got here. Another example, here we have this as the alpha carbon, this one is the alpha carbon. We have two alpha hydrogen. When this will be reacted with OH minus and heat, then we will get this as the product. This is alpha beta unsaturated carbonyl aldehyde. This is the product. These are some examples of aldol addition product and aldol condensation product. Same, we can draw out mechanism of all the reactions with what we have learned here in this chapter. So this is about the aldol reaction and aldol condensation reactions. Next we'll look about cross aldol reaction. Now we will look about cross aldol reaction. Cross aldol reaction means the two equivalents of aldehyde or ketone that we were using, initially both were of same compounds, both were same molecule. But now we will see aldol reaction between two different molecules. So we can have two cases here. First, in which the compound two equivalent, one is A, another is B. One may have alpha hydrogen and another may not have alpha hydrogen. And case 2, both may have alpha hydrogen. So how reaction will proceed? Let's see. The first case where alpha hydrogen is present in one compound and another compound does not have alpha hydrogen. So how it will proceed? Here we have formaldehyde and acetaldehyde. Here we can see this is alpha carbon, and here formaldehyde, this does not has alpha carbon. So this will not form enolate. This will form enolate, and then this will go and attack on this. This will become nucleophile and this will attack on this carbonyl. So how reaction proceeds? First, this OH minus will go here and this will extract one hydrogen from here. This will extract one hydrogen from here, and then it will form CH2 minus CHO. Then again this will go and this will attack here on this carbon, and this will move further here. This is nucleophile, and oxygen being more electronegative has attracted more shared pair of electron towards itself. So this has little bit deficiency, for which it is acting as like electrophile. This enolate has done here nucleophilic attack. This will attack here. Then we will have this compound. This is the new CC bond which is formed here. Then we will protonate this one, and we have got this beta hydroxyaldehyde. This is aldol addition product, and heating it in presence of base, we have got this alpha alpha beta unsaturated carbonyl, that is aldehyde here. So this is the example of case 1 where one compound was having alpha hydrogen and other was not having alpha hydrogen. So this was case 1. We can have also case 2 where both the compounds have alpha hydrogen. So how the reaction will proceed, we'll see now. Now come to case 2 where both the compounds are having alpha hydrogen. So we can get more than 2 products here. This is alpha carbon and hydrogen is present here. This is alpha hydrogen and this is alpha carbon. We can form enolate from here also and from here also. When we will form enolate from here, OH minus will extract this alpha hydrogen and will have CH2 minus CHO here, and then this will go and attack on another compound, and we will have this one as the compound after this reaction. This is the new CC bond formed here, and when this will be heated in presence of base, then we will have this as the final product, aldol condensation product. When this hydrogen will be extracted by OH minus, when we will have this enolate, then this enolate will go and will attack here. This will further move here as here, and then we will have this as the product. When this will be protonated, then when this will be protonated, then we will have this as the aldol addition product, and when aldol addition product, this will be treated with OH minus and heat, we will get aldol condensation product. So this is all about aldol addition and aldol condensation product. Now come, let's summarize this. The most important thing that we have to keep in mind is that we should have reactant as the carbonyl, that is aldehyde or ketone, and that must have alpha carbon where at least one hydrogen should be present, alpha to the carbonyl group. When this alpha hydrogen containing carbonyl group, when this will be treated with base, reagent will be base, then we will have the product as aldol addition product, and when aldol addition product is treated with base and heated, then we will have aldol condensation product. Aldol condensation product is also known as alpha beta unsaturated carbonyl, and aldol addition product is known as beta hydroxy carbonyl. When aldehyde, then we will say aldehyde. When ketone, then we will say ketone. So we get this as the product here. This is all what we have learnt about aldol product. Now we will meet next time having some another reaction. Thank you.